Determine the convergence or divergence of the series. Identify the test or tests that you use. There may be more than one correct way to determine the convergence or divergence of a given series. Now this one has a bunch of exponents in it, and if it has a bunch of exponents in it, we probably want to use the ratio test. So the ratio test says the limit as n goes to infinity of the next term in the series sequence divided by the current term of the sequence. Now, if you do this from the very beginning, you find out that you're going to have an algebraic problem. So let's actually show you what that problem is going to be. So I have a 2 to the n plus 1 over 3 to the n plus 1, because that's the next term in the series if the current one was 2 to the n over 3 to the n plus 1. And then we're going to add 1. And then we're going to divide that to 2 to the n over 3 to the n plus 1. And if you flip and multiply, you end up getting 2 to the n plus 1 over 3 to the n plus 1 plus 1. And then you get 3 to the n, 2 to the n, no, plus 1, and to the n. Now this right here will never reduce with anything down here, which means we start getting stuff that we have no clue what's going on. So we find out that the ratio test is not going to work at this point. So what I'm going to do is a direct comparison test. I can pretty much say that if I take the summation of 2 to the n over 3 to the n, this from n going from 1 to infinity, this will pretty much be less than this, mainly because if I add 1 to whatever on the bottom, it's going to make this smaller. So this will always be smaller than this. So if I can prove that this converges, and if this is smaller than this will also converge. So now I'm going to do a ratio test on this. So I'm going to take the limit as n goes to infinity of the next thing in the series. So the next thing in the series is going to be 2 to the n plus 1 over 3 to the n plus 1. And then we're going to divide that to the current one in the series, so 2 to the n over 3 to the n. And this equals the limit as n goes to infinity. Now I'm going to rewrite this right here, and I'm going to use an exponential rule. So we know that b to the x plus y is the same thing as saying the b to the x times b to the y. So this is going to be 2 to the n times 2 to the 1 over 3 to the n times 3 to the 1. And we're going to flip and multiply this piece right here up to the top, which will give me 3 to the n on top, 2 to the n on the bottom. This goes away with this goes away with this. And the limit of this is actually going to be 2/3. Now this is less than 1. And if that's less than 1, then we know that the integral from n equals 1 to infinity of 2 to the n over 3 to the n converges by the ratio test. Therefore, the summation of n equals 1 to infinity of 2 to the n over 3 to the n plus 1 also converges by the direct comparison test. So I used 2 tests to do this one.